Systems of equation by graphing. Number one, it says Natalie has a system of equation with no solution. So I know if equation has no solution, if it has no solution, that means I have to have the same slope and I have different y-intercepts. And also the lines must be parallel, so it's all of the above. Number two, it said which equation will have infinitely many solutions. I know if I have infinitely many solutions that my graphs will be the same as my line. So here, my y-intercept is 0. So therefore my b is 0, 1. My slope is a rise of 1 and a run of -2. So my slope is -1/2. So my equation is y equals mx plus b. So I need another equation that has the same, another equation that has y equals -1/2 x plus 1. So if I do number 3, if I do letter D, subtracting x from each side, this gives me y equals -1x plus 2, so it can't be D. Letter C is exact equation as D, because if I divide everything by 2, I get x plus y equals 2, which is the same as D, so that can't work. Here, if I add 2x to each side, I'm left with y equals 2x plus 1, so that can't be correct. Here, if I subtract 3x from each side, I'm left with x plus y equals, let me back up, not left with no x plus y. This cancels and you're left with 6y equals -3x plus 6. Divide everything by 6. You're left with y equals 1/2, -1/2 x plus 1, which is the same as that equation. So you should have had A. Number 3, it says solve each equation by graphing. I'm going to put this in slope-intercept form by subtracting x on both sides. So y equals -1x plus 5. If y equals 2, that's a vertical line. Do -2. Horizontal line through -2. Or horizontal line through -2. This is y equals -2 right here. And then here, y equals -1x plus 5. My y-intercept is 5. My slope is -1. So that's a rise of 1 and go to the left, rise to the left, or down 1 to the right, down 1 to the right. I'm going to keep going down 1 to the right till it intersects. So it intersects at this point. So this is my point of intersection. So my solution is 7, -2. Second one here, I'm going to subtract 2x on both sides and put it in slope-intercept form. That gives me -2y equals -2x minus 4. Divide everything by -2. Y equals x plus 2. So my first equation, I'm going to graph. My y-intercept is 4. I'm going to rise 1 and go to the right 2. Rise 1 to the right 2. Rise 1. to the right 2, or go down 1 to the left 2, down 1 to the left 2, draw this line. And for my second equation, my b is 2 and my slope is 1. So y-intercept of 2 slope of 1, I'm going to rise and run, rise 1 to the right 1, 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 and draw your line. So my point of intersection is right here. So my solution is 4, 6. Number 5. Number 5, I'm going to graph the first equation. My y-intercept is 2. My slope is negative 1, which is a rise of 1 to the left because it's negative. Rise 1 to the left, rise 1 to the left, or down 1 to the right, down 1 to the right, down 1 to the right. And draw your line. And the second equation, which is 3x plus 3y equals negative 6. I'm going to subtract 3x on both sides. This cancels, and I'm left with 3y equals negative 3x minus 6. Dividing everything by 3. Y equals negative x minus 2. So my y-intercept is negative 2. My slope is negative 1. So I'm going to rise and go to the left, 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 rise and go to the left. And as you can see, I should have no solution because my slopes are the same. The slopes are negative 1 and they have different coefficients. So for this answer, it's no solution. Number 6, we're going to plot the first one. My y-intercept is 5. My slope is negative 2/3. Y-intercept is 5. Go down 2 to the right 3. Down 2 to the right 3. Or I can go up 2 and to the left 3. And draw your line. For the second equation, we want to add 2x to both sides because we're trying to put it in slope-intercept form. This cancels and you're left with 4y equals 2x minus 8. Divide everything by 4 and y equals 1/2 x minus 2. So my y-intercept is negative 2. My slope is rise 1 to the right 2, rise 1 to the right 2, rise 1 to the right 2, rise 1 to the right 2. So you can see this is one solution, and my point of intersection is 6, 1. So that's my solution. Number 7. Number 7 said Judah bought a container of gingerbread house kits, the gingerbread cookie kits to decorate the holiday event. The house kits is Y, was one more than half of the number of cookie kits. Judith bought a combination of 10 gingerbread houses and cookie kits. What's the following systems of equation represent this situation? So if house kits is Y, that means cookie kits must be X. Cookie kits stands for X. So we want to graph both of these on a graph. Put this in slope-intercept form, which is y equals negative x plus 10. My slope is negative 1. My y-intercept is 10. So 10, go down 1 to the right 1. Or up 1 and to the left 1. And draw your line. And for the second equation, my y-intercept is 1. My slope is 1/2. So graph your y-intercept and rise 1 to the right 2, 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 and draw your line. So my point of intersection is here, which is the point 6,4. So here my point of intersection is 6,4. So we graphed the system of equations. Says how many gingerbread houses did she buy? Since X represents cookie kits, that can't be gingerbread houses. So we look here for Y. It's house kits. Y in this case is 4 and X is 6. So she bought 4 gingerbread houses and 6 cookie kits.